here's page 3, the notes for section 10.2. So there's some stuff at the top of the page that I'm going to read through, and then I'll talk about what's going on with these columns in example number 4. So at the top of the note sheet it says, one more thing. What about something like 16 to the 3/4? Well, using the rules of exponents, we can think about this in two different ways. Okay, so one way we can think of it is 16 to the 3/4 can be broken down into 16 to the 1/4 to the third power, right? Because if you remember, the rules of exponents say a power to a power, you multiply those two exponents, right? And 1/4 times 3 equals 3/4, right? So we're taking 3/4 and like factoring it into two separate things, 1/4 and 3. Okay, so what that means is 16 to the 3/4 is taking the number 16 and doing two separate things to it. The first thing you're going to do is you're going to find the fourth root of 16, because 4 is in the denominator of that fractional exponent. The fourth root of 16 is 2. Okay. Now after you do that, the second thing you do is, since the numerator part of the fractional exponent is 3, that means you're taking the result of the first step and raising it to the third power. 2 to the third power is 8. Okay, so 16 to the 3/4 equals 8. The fourth root of 16 is 2, 2 to the third is 8. That's how that works, okay? Now the order doesn't matter, right? You can do this, you can take the root first and then raise it to the power, or you can do the power first and then find the root. So you could take the same 16 to the 3/4 equals 16 to the 1/4 to the third, since, again, 3 times 1/4 equals 3/4. So that means that 16 to the 3/4 equals, now check this out, now instead of taking the root first, I'm going to do 16 to the third power first. 16 to the third power is 4,096. Okay. 4,096, the fourth root of that, what times itself 4 times gives me 4,096? Well, guess what? It's the same as what we got in the first sentence. It's 8. Okay? So what that means is, again, it doesn't matter if you do the root first and then the exponent, or the exponent first and then the root, you will get the same thing. However, some ways are easier than others, right? So sometimes it makes more sense to do one versus the other. Okay, now on to example number 4. Two things that you got to do here is, first you have to connect each of these exponential forms with their associated equivalent radical forms. Okay, so all right, so let's see. So here I've got 8 to the 2/3, which means I'm doing the third root of 8 and then squaring it. Okay, that's that. It's also the only one that has 8, so I could use that hint too, but anyway, that's what we get for the first one. The second one, 100 to the 5/2 means I'm doing the square root of 100 and then raising it to the 5th power. The square root of 100 and raising it to the 5th power is this one. Okay. Here, okay, 1/25 to the 3/2. Well, again, I'm taking the square root of 1/25 and then raising that result to the 3rd power. That looks like this one. 4 to the negative 3/2. Well, this, I think, so the 4 is going to end up in the in the denominator of a fraction, because I've got a negative square root, or a negative exponent. So that looks like this, right? And it makes sense because this is telling me square root and then raise it to the 3rd power. Looks like that. Okay, negative 81 to the 3/2. That means the square root of negative 81 and the whole thing, right? Because that's in parentheses. And then raise the result to the 3rd power. Looks like that. And then there's only one left. So by process of elimination, the square root of 9 to the 3rd power is right up there. Great. All right, well, so now for the second step is to actually simplify these things. Let's just go from the top to the bottom. Okay, starting with the square root of 1/25 to the third power. Well, the square root of 1/25 is the square root of 1 over the square root of 25, which is the square root, or it's just 1/5. And then that to the third power is 1 over 125. Yep. Okay, great. The next one, the square root of 9 to the third power. Well, square root of 9 is 3. Then I got to raise it to the third power. 3 to the third power is 27. Okay. All right. The third root of 8 to the second power. Third root of 8 equals 2. 2 to the second power is 4. Square root of 100 to the fifth power. Square root of 100 is 10. 10 to the fifth power. Let's see, I don't know. It's a 1 with 5 zeros. Can I fit it? 100,000? I think that's right. Great. Okay. 1 over the square root of 4 to the third power. The square root of 4 is 2. 1 over 2 to the third power is 1/8. And then finally the square root of 81, or rather the square root of negative 81 to the third power. No real roots, because there is no real square root, negative 81. Okay.